Graphing linear inequalities. Review. I don't know. Shush it. Okay, what does that say? Guys, time to be quiet now, okay? Oh, good. It says y equals mx plus b. What the heck is y? It's the y coordinate. Usually, it's vertical. And it will be for you guys, always, okay? Yes, y is the vertical guy. X is the horizontal guy, without getting into domain and range, but we will, but not today. Or independent or dependent variable, which we will, but not today. Okay, so we did we did y, so let's do x. X is the x coordinate, right? And there may be infinitely many. And if this is some line with arrows on it, there are an infinite amount of points. Actually, just from there to there, it's an infinite amount of points. Okay? Because that's what a line is. It's just a whole bunch of dots put together. What is M? M stands for? That's the other letter. Slope, right? It's the slope of this line. Slope is a measure of how steep it is. Really, really big number, really, really steep line. Like just off of infinity is like 90. Big number, right? Let's go 900, even bigger. Got another zero there. Okay, really, really steep line. If it's vertical, you recall, you can't do that, right? That's an infinite slope. We just say it's undefined. You can't do it. And if it's completely horizontal, then the slope is zero. There's no steepness to that line at all, right? It's a horizontal line. And I talked about skiing in grade 10, and that's a boring way to ski. It's called cross country. This is pretty exciting. So, last letter. Someone already said it. B stands for the Y-intercept. Okay, which in this case is right there. That's where it crosses the y-axis. Slope we can calculate because by definition, not just in math but in science, it is rise over the run, right? So slope is rise over run. The more rise it has, the steeper it is, given its run. So, most of you guys last year, or some of you guys last semester, when I said graph that thing, you got a mark for this. How do you graph it? Well, here I have nice graph paper, so this is going to be nice, but if you don't, you can still do it. If you guys didn't get any, like I asked you to, and you still have line paper, you can still graph it. How do you graph it? Well, I'm going to show you two ways. In grade 10, I would say start with the y-intercept, because you know it has to go through that point, right? Has to go through the y-intercept. That is 1. Okay? So if you guys don't have on your line paper, whatever, you can use that, or if you don't, just put a line there. That's where 1 is. Okay, that's step 1. I know the line goes through there. Don't do this, but I don't know if it goes like that, like that, like that, like this, maybe like that. Like, there's tons of options here. But I do know it goes to that point. How do I graph the line? Well, I look at this, and I go, that's my slope. That's rise over run. There's a number there. It's not just 2. That's the rise part. Where's the run part here? 2 can be written like what? Is that the same number? It is. Okay, it's 2 over 1. That's the rise, that's the run. So then I take this point and I rise it to 1, 2, and then I run it 1 unit. But what direction do I go? Do I go here or do I go there? Then I got to think, well, this is a positive slope. So I have to go here. Because I told you in grade 10 that positive slope lines look like that. Okay? They tilt to the right. Negative slopes all kind of look like that. They tilt that way. Okay? Those are all negative slopes. Okay? How many points do I need to graph a line? That's it. I got my 2 points. I got the y-intercept, 1, and I've got my slope, 2 units of rise, 1 unit of run. Okay? 2 units of rise, 1 unit of, how do you spell run? R-U-N. Okay? Now, if you want to make a nice straight line, I can keep doing this. From this point, if I rise at 2 units of rise, 1 unit of run, it should go through there. Let's actually make this bigger. Okay? And if I go down from this point, that's 2 units of rise, 1 unit of run. I don't want to go this way, because that's not where the line is. I want to go this way. There's a point. 2 units of rise, 1 unit of run. See, my line wasn't very good. It's actually there. 2 units of rise, 1 unit of run. So my line, if I'm really picky, should do that. Okay? Yeah, I'm going to blame the electronics here. I'm better with a pencil and paper. This thing does a little strange things. Okay? All right, so that's one way to do it. And you can do it that way. But I'm going to teach you to do it a different way. Because it's all lovely if it's actually in that form, y equals mx plus b, but you're going to get equations that aren't. So how many points do you need to do a line? 3. You only need 2, right? Any 2 points, now you know where the line is, right? You know where the line is. All you need is 2 points. So we're going to do this finding the x-intercept and y-intercept. Do you remember doing that stuff? Yeah, well, you need to get pretty darn good at it. In a hurry, or you're not going to do well on this test. We'll be doing this the whole chapter. So again, my little big kid speech, if you're not getting this, you come in at lunch and find out. Otherwise, it's going to come to bite you in the butt real fast. And there will be a point where you can't catch up anymore. Okay? So, what happens at the x-intercept? What is an x-intercept? That's where it crosses the x-axis, right? This guy crosses it right there. What do you know about the y-coordinate right there at the x-intercept? Y-coordinate is 0. Okay? I don't care where a line goes through. At the x-intercept, y is 0. This line, at the x-intercept, y is 0. I don't care what line you draw, every x-intercept, y is 0. Okay? That's what we do to solve for this point. Get rid of that garbage. So for this equation, y equals 2x plus 1. Y is 0. I'm going to substitute that right in there. So 0 is 2x plus 1, and I will do that to solve for the x-intercept. So, good old algebra. How do I solve that thing for x? First, get rid of the plus 1 by subtracting minus 1. Whatever you do to one side, do to the other side. So I got negative 1 is 2x. That's one step. Second step, how do I isolate for x? How do I get rid of that 2? Divide. Whatever you do to one side, do to the other side. So my x-intercept is negative a half, how do I write that as a coordinate point? Well, that's the x coordinate. What's the y coordinate at the x-intercept? Yeah, it's 0. That's how I did this thing, right? So negative a half, 0. There it is. There's my x-intercept. How many points do I need to do a line? 2. Oh, I'm using red. Sorry about that, Mateo. So that's the x-intercept. Now I'm going to find the y-intercept. Now I know the y-intercept is 1. This is in that form where it tells you what it is. But let's pretend you didn't get this equation. What happens at the y-intercept? X is 0. Always, always, always. That line intercepts the y right there. That's where x is 0. This line, x is 0. Always, always, always. So I'm going to go y is 2x plus 1. I'm going to substitute x 0 here. Y is 2 times x is 0. And then I got to solve that thing for y. Well, what's 2 times 0? 0. What's 0 plus 1? That was easy. That's the y-intercept. What is that as a coordinate point? X is 0. Y is 1. But we already knew that, because that's right there, right? So that's how we're going to do these. 2 points, x and y intercepts. Okay? So that is review. This is an equality. We want to do inequalities. So this is not grade 11 math, kids. This is grade 10. To bring it to math 11, now we got an inequality. That happens to be the same equation. Okay? But what does that less than thing do? Well, you remember, if it's less than or greater than, you can't include the point. Cannot. We could also have this. Less than or equal to. You know what this says? In English, that says every point of y which is equal to double x plus 1. The solution for that is everything on this line. That's it. But if I don't have an equal to, if I just have a less than or a greater than, then that line's not solutions, and I'm going to dash it. Okay? So I want to graph this. I've already done this. So step 1 would be solve for the book has a word for it, boundary line. And we just did it. Okay? That's the line that I just did. And this is what we did you to grade 10? No. This is what you learned in grade 10. Better said in English. So I'll say it again. If they give it to you in y equals mx plus b form, then you can do that. But going forward, I'm not going to teach it like that. I'm going to use x and y intercepts. Okay? So first step is just pretend there's no inequality. Pretend it's a line. So I have my x and y intercepts. I already did them, so I'm not going to do it again. But on the next question, of course, I'll do the whole thing from start to finish. And I'm going to do my boundary line. So I got, it's not very good, negative a half, which is half of a line, and 0. That's 1 point. The other point is 0, 1. Okay, and it's tough to do that line because those points are so close together, but The point here is you don't make it solid. What color do I want? Green. It's a dashed line because it's greater than or less than. If it said that, that says less than. If it says greater than, you just dash it. I'll say it again. Because this line isn't a solution. The points on this line don't satisfy this equation. It's not equal. Okay? If it's equal, I'll make it a solid line. Okay, so let's make a point about that. If we have less than or greater than used dashed line because points on the line are not a solution to that equation. Okay? Let's flag it just because I can. So the new part is the inequality, so we got a dashed line. But so what is the solution? What this says in English are, what are the values of y which are less than 2x plus 1? I'm going to shade one side of this dashed line. Either it's the left-hand side or the right-hand side. If other questions are like this, then you're going to think top or bottom. One side's going to be a solution, okay? What side do I shade? And what I need to do is, step 2, use a test point. To determine which side to shade. Okay? The shaded part's going to be the solution area. So, what point do I want to use? I can use any point I want. If it works in this equation, then it's a solution point, and I'm going to shade the side where that point is. And if it doesn't work, I'm going to shade the other side to where the point isn't. What's the nicest point I could possibly use, do you think? A coordinate point. There's one easier than, if you're thinking 1 for x, 1 for y. Yeah. 0, 0 is nice, right? We like zeros because anything times 0 is just 0. So this one's kind of hard to see, but if I want to use 0, 0, what's a nice color I'll stand out? Blue. Do you see clearly what side of the dashed line that is? I do. Do you see clearly what side of the dashed line this is? Yeah, it's the right side or the lower side, okay? So if you can, use 0, 0. Okay, let me make that smaller again. If you can. If this line, it's not clear where that point is, then I got to use a different point. You can use whatever heck point you like, okay? But this is the easiest. So, substitute this in the equation. And see if it works. What's my equation? Y is less than 2x plus 1. Let's put that point in there and see if it works. 0 is less than 2 times x is 0 plus 1. Does that work? I don't know. Let's simplify it. What's 2 times 0? 0 plus 1 is 0 less than 1? Yeah, of course it is. Right? Would you rather have no bucks or $1? I'd rather have more money. 0 is less than 1. So therefore, 0, 0 is in the solution area. So I'm going to shade the area with that point. Like that. First, let me finish. That's the solution. That's the answer. Every single point on the right-hand side of this line satisfies that equation. Okay? Here. So I'll give you a sec to completely copy that down, and then I'll test another point, just to show you. Okay? So every point that I shaded there is going to work in this equation. Let's pick good old, who said 1 and 1? Does it work? Is 1 less than 2 times 1 plus 1? Is 1 less than 3? Yeah. Let's try this point over here. Let's go crazy. 1, 2, 3, 4, 5, 6, and 2. Is 2 less than 2 times 6 plus 1? Yes. Every point here satisfies, which means if I took that point, is it going to work? It better not. Let's check it. What is that point? Negative 3 and 2. That shouldn't work in here when I plug it in. So y is 2. Is that less than 2 times negative 3 plus 1? Is 2 less than negative 6 and 1? In other words, is 2 less than negative 5? No. Not a solution. It doesn't work. And every point in here and down there, remember this line goes on forever and ever and ever. None of those will work in there. Okay? Again. Okay? So I know that's a little bit to absorb, especially on a Monday, but this is 20% of the school days that you have, right? So I will do another one from start to finish. One that doesn't look like y equals mx plus b. Solve. There is a linear inequality. What does it mean, solve? It means graph it and then shade the solution side of that line. So what do I do? Step 1. Find the boundary line. In other words, pretend this is grade 10. Pretend that's what you got. Graph it. Is that in the form y equals mx plus b? No. It's the wrong nod to your head. Feel free to make that y equals mx plus b, but why bother? How many points do I need to do a line? Find the x and the y-intercept and do the line. Okay? So x-intercept, what happens at the x-intercept? Y is 0. Substitute that in there and solve it for the x-intercept. What's negative 2 times 0? Yeah. 0 and 2x is 4. Divide both sides by 2. That's the x-intercept. What's the coordinate point? X is 2. What's y? It's 0. Yeah, there's 1 point. Here's my graph. 2, 0. Only need 1 more point, and I know where the line is. So, next one's going to be the y-intercept. What happens at the y-intercept? X is 0. Always, always, always. Substitute it in this line and solve it for the y-intercept. And make sure you write this down so you know what you're doing. Because lots of kids will just put these numbers in here and then all of a sudden they do all this algebra. They don't even know what the heck they're doing. I'm solving for the y-intercept. That's why I'm writing it, okay? I'm not doing this for me. I'm doing this for you guys. So minus 2y plus 0 is 4. How do I solve that for y? Add. Is it negative 2 plus y? It's negative 2 times y. What's the opposite of times negative 2? Divide negative 2 away. Y is negative 2. That's the y-intercept. What's the coordinate point here? X is 0. Y is negative 2. Which is right there. You see where the line is? Am I going to draw a line? Not so fast. I want it to be dashed, remember, because anything on that line doesn't satisfy this equation. It's a dashed line. If that makes sense, great. And if it doesn't, then you got to memorize, right? If you don't have an equal there, don't make a solid line. It's dashed. Just roughly, okay? I don't need a billion points here to make it exact. I just need to know what side to shade, right? Solve. Is it the top side or the bottom side? So step 2 is what? Figure it out, yeah. How do I figure it out? Use a test point. Put it in the equation and see if it works. What's the nicest test point to use? Yeah. I can use that. I can clearly see if that's going to work or not. That's definitely above the line, 0, 0. So put that in here. Done already? Negative 2 times 0 plus 2 times 0. Is that less than 4? That's 0. That's 0. Add them together, you still got 0. Is 0 less than 4? Yes. Okay, so 0, 0 is a solution. And everything around it will be a solution. So don't spend all day here, guys, by coloring with your magic crayons. Just 5 lines. That shows me where the solution is. Okay? Comprende? So if I try one of these, excuse me. If I try one of these points down here, is it going to work? No. If I try a point right on the line, is it going to work? No. Do you want to prove that? Yes, you do. This is right on the line, isn't it? Because that's how I made my line. So if I put that in here, if y is negative 2 and x is 0, does that work? It better not, because I told you it doesn't. That's positive 4 plus 0. Is that less than 4? No, it's equal to it. That's why I dashed the line. Because that right on that line, that's not a solution. It's just everything above that line. Everything less than or greater than. Okay? You wishing you're doing triangles still? Oh, okay. You're sick of triangles. No, you're not sick of math. Page 303, 1, 2, and 5AB. That's it.